this. So you're going to go ahead and watch the video where you're going to see the movement. So you see them start here, end here. So you know how many degrees they're going to have moved through. It's okay to use effectively a protractor on your screen otherwise to estimate how much that joint is going to be rotating. Now, obviously, you can figure out what muscles are going to cause it to move in that direction during that phase. Then, now that you got the degrees that it's moved, well, that's for that phase. You know how much time it took to do that. So that's your velocity, your rotational velocity, degrees per second. Now, the acceleration is when you're going to then look at the velocity from that phase and the previous phase. So it's just starting. So we're going from, so you're at the end of the windup, we're going to have effectively a negative velocity and then you stop. Okay. Then if you're going to go ahead and throw a ball, you're going to in turn have a positive acceleration for the first part of throwing the ball. Then when you let go of the ball, you're going to have a deceleration when you come through at the shoulder joint. So you're going to simply look at your starting velocity, your finishing velocity, and the period of time it took to go over that distance. So really all you have to do is take the amount of degrees you moved in that period of time, in some cases, and simply divide it by time squared. Make sense? From there, we've got those estimation examples that you can figure out how much each of those areas of the body weigh, and then you know how long those levers are. So if you know the mass of that area of the body, and then whatever object they might be holding, so if it is like a baseball bat or otherwise, you've got that extra mass that is being moved. From there, you're going to be able to do your own leverage formula, where you're going to try to figure out, okay, based upon the fulcrum being at this location, this is how much resistance is pulling us down. So then given our effort arm, so how far away that muscle inserts into that fulcrum, how much force it's going to have to produce in order to lift it. And then we go back to our equation where our torque equals our inertia multiplied by our angular acceleration. So you will literally have everything you need. Questions, comments, concerns, guys? When you're ready, go ahead and give me your groups in the chat. Thank you, Catherine. I greatly appreciate you being on the ball. And I'm going to start working on getting you guys into those breakout rooms. That's okay, Roland. If it's just the two of you guys, even better, because then you guys can focus on, because once you have this answer, guys, that's one major part of your actual assignment of your project. All right, guys. Thank you guys for the heads up. I will make sure we get everybody in that's a little bit late, and they should be able to join those groups. So work in your groups and work on trying to solve for those portions. The goal is that you guys are going to have about, let's give you guys 15, 20 minutes to try to get through just one of the joints. You don't have to solve for all of them. And then we'll come back and we'll kind of talk about and figure out what issues you guys have. And I'll check in on you guys as we're going through. So work hard together and we will chat in just a few moments. Have fun, guys. For Braden's question, when we're trying to figure out the insertion for the ankle, first and foremost, we're really talking about the gastroc and the soleus, which are going to be the major plantar flexors. Don't get me wrong, there's a number also that are helping out, but we're not going to be worrying about them too much in this example. Now, this is going to be straight from behind, which is slightly problematic, since obviously what we're interested in is looking at how much is actually being produced. So then we notice I just literally put that in there. And it's funny is this is actually someone's question, notice from their biomechanics class at BYU. So first and foremost, you can always use the power of the Googles. But take a look. And there's the solution to your problem. And guys, you're going to be able to do the same thing with pretty much every single muscle in the body. And that's really all you're looking for. Now, that one's simple because we're only looking at the gastroc and the soleus are feeding into the calcaneus tendon. Both of them obviously are going to be helping lift. And you can assume the total force is being produced by both of them. We're not going to worry about the percentages of each. That's beyond what we're looking for you guys to do. And honestly, outside of slicing something off, it's going to be something that's really hard to figure out. But it'll also be influenced by what we'll get to, which is active and passive insufficiency. But we're not there yet, so don't worry about it. Now, the other thing that we'd have to go ahead, it'd be more complicated, is let's say something like you're doing a pull-up. When you're doing the pull-up, and we're talking about going from essentially from flexion to extension of the shoulder, the sternal lower fibers of the pec, the lat, the teres major are all pulling us down. Each of those is going to have its own insertion on the humerus at different distances. And those distances in turn are going to give us their own individual little kind of moment arm, which is going to make things a lot more complicated. So instead, in that case, guys, just take the average insertion distance. Just run that. I'm not going to have you guys worry about trying to get into that level of minutia. But for the love of God, don't make it sound like the posterior delta is doing most of the work there. I've had students try to argue that, and that's just hella wrong. So, what other questions you guys want to work your way through or need a little help with? And this could be review questions for the exam.
How would you find like the weight of the muscle?
The weight of the muscle?
Or like, so the weight of the thigh, or does that make sense?
Yeah. There should already be some of those options up there. Give me 1 second. Because it turns out the way that I get to see things for biomechanics is different than how you guys see it when we're up on the joys of Blackboard. Okay, because I know you and I actually had this conversation. So, 2 things. Project example, this knee sweep presentation is probably, this group got an A on it. So it's a really, really great example of how we're having you try to go ahead and do it. Now down here, we have another example of how to find the center of mass, and that's going to be in that presentation that you guys are going to be able to go ahead and pull from. Okay.
Gotcha. Thank you.
Yeah. And so, yeah, you go in there and now those are a couple good examples. Now give me a second. And I've got a good link and I'll drop that in here real fast for you guys to be able to look at. This is one of my favorites. Because notice, guys, here, percentage of total body weight, how much each of those different areas of the body are going to be. And what's also better is not only do you have a couple different ways of approaching it, but then notice also here's your center of gravity. So you literally have your point of which you're going to find that center of mass. So you don't have to worry about trying to figure that out. And notice lengths is based upon total height. Now, in theory, at the anthropometrics lab, you guys have already done this, so you don't need to use this, but it does give you guys another option of how you can go about it. And notice, guys, the references. So boom, you're going to go ahead and make sure that you drop these in for your references in your paper. Hey guys, the goal is for you to learn, but not to punish ourselves with it. Good. Haley, so the basic idea is you're going to be multiplying the length of the segment by that percentage, and that's where you're going to find the center of mass for that segment. While we're still talking, I'm going to go ahead and put that link up under the old presentation with center of mass data, so you guys also have that link up there in Blackboard. So you can draw from it whenever you need it as well. Is there anything else you guys would like to work on reviewing? Well, guys, since everybody seems to be pretty quiet, okay. Would we only do the arm that is hitting the ball and you break down the arm that is holding and throwing the balls? Awesome. Those are two separate actions. So the squat and the deadlift group, the body should be doing the exact same movements on both sides. But with the hitting the volleyball, you've got two different movement patterns. So you should have effectively one person who's in charge of the hitting arm and one person who's in charge of essentially the other arm. So they're each their own breakdown. Don't worry about having to do both of them. You only have to do one joint when obviously that joint has a very different action than the other one. So the group that's kicking the soccer ball, you can have the kicking leg and the support leg. So each does their own. Okay. So find the force arm length for the ankle. Okay. If you are talking about, okay, good. So let's go to Braden. Here's the thing. If we are going to do this two separate ways, one of which is the leg that's on the ground, okay? The leg that's on the ground, so the support leg, okay? Your fulcrum is the ball of your foot. Your resistance is, yes, your entire body weight, not just your leg, but obviously your hip, the entire body above it. But that is being lifted by the calcaneus tendon with the gastroc and the soleus behind it. Obviously, this is not to scale. Now, for the other leg, that is effectively kicking the ball. The sound effect for there is pew. We are going to have the fulcrum is the ankle joint. The tibialis anterior is what's trying to keep your leg from being broken off. And so you're going to have the center of mass of the foot and the center of mass of the soccer ball with wherever it happens to be making contact with the foot. So you got those two resistances and lifting there. So your resistance length, all of the weight above in the body is literally just going through the ankle. And then you have the center of mass of the foot pulling you down in that support leg. But your kicking leg, you only have the soccer ball and then the weight of the foot. Does that clarify things? Good, good. Anything else you guys want to talk about? Yes, because the knee action during the deadlift and the squat are very, well, yeah, they're definitely different. They're definitely different. For sure, for the squat and deadlift guys, definitely be breaking down the hips and the knees. From there, you could possibly do the ankle, and obviously you can do the shoulders and the back. More in the, especially the shoulders more in the deadlift and the squat, don't put your energy into it. It's not worth the time, but the back is definitely one. And you can differentiate between the low back and the upper back. Okay, for the serve, it depends on the motion. And remember, you're going to also incorporate the deltoid, possibly the lats, teres major, and then don't forget you have your rotator cuff that's stabilizing it. Anything else you guys want to talk about? It's not so much the insertion is different with each phase. You might be using different muscles. As in, they're going to be performing concentric, so shortening actions, and they're also going to be performing eccentric, aka braking actions. So each of those actions are going to obviously use different muscles. So the muscles, like if you're throwing a baseball that give you internal rotation, once you get done and you're releasing and then you're deaccelerating your arm, that's actually being deaccelerated by your external rotators of your arm. So you have to make sure that you account for which muscles are being used during which phase. All right, guys. Well, nobody else has got anything else that they want me to go ahead and cover. We'll go ahead and let you guys go early. We are going to be lecturing a little bit next week, but obviously you guys are going to have your exam. So make sure you guys go through that study guide, be ready to go. And otherwise, stay safe out there, guys. Have yourselves a great day. All right. Bye-bye.